Welcome back to Python Unlocked. We are exploring different types of operators in Python. As of now, we have covered arithmetic operators, logical operators, and we have also discussed about the comparison operators. So in this video, we'll dive into bitwise operators and assignment operators. So without wasting any time, let's get started. Okay, so the very first that we will deal with is a bitwise operator. So what are bitwise operator? Bitwise operator deals with binary representation of the integer and they operate bit by bit. Now, what does this mean? For example, I am having any variable, let's say, for which I am assigning value 4. I am having other variable 2, let's say b, for which I am assigning value, let's say for time being 2. Now, what we supposed to do? We supposed to deal with the binary representation of integer. And what will be the binary representation of this 4? That will be, if you remember the conversions, 8421. Okay, so what will be the code for 4? That will be 0 1 0 0, whereas for 2 that will be 0 0 1 0. Now remember this, they will operate bit by bit. That means what we supposed to do, the very first operator that we are having as a bitwise AND, what we are doing in that, if each bit set, the bit will be set to 1 if both the bits are 1. Take a simple example. As it's operating bit by bit, see over here for this, remember this scenario. If I'm having 0 0 in AND, I'll be getting 0. If I'm having 1 0 in AND, I'll be getting 0. If I'm having 0 1, again I'll be getting 0. If I'm having both the bits as a 1, I'll be getting 1 as output. So remember this, for this particular 0 and 0 will be 0. For 1 0 it will be 0. For 1 0 it will be 0. For 0 1 it will be 0. For 0 0 it will be, eventually it will be 0. So this is the, if I try to convert, if I try to apply the bitwise AND on the value 4 and 2, I'll be getting 0 as the output. Whereas if I deal with the OR, in OR, remember that if any of the value, if any of the input is 1, I'll be getting 1. That means 0 and 0 will be 0, 1 and 0 will be 1, 0 and 1 will be 1, 1 and 1 will be 1. That means if I try to apply a OR operator on 4 and 2, what output I'll be getting? I'll be getting 0 and 0, 0, 0 and 1 will be 1, 1 and 0 will be 1, 0 and 0 will be 0. That means the output that I'll be getting at the end, that will be 6, because this 4 means, this 1 means 4, this 1 means 2. 4 plus 2 will be 6. The output that I'll be getting at end will be 6. Okay. Okay, so I hope this a bitwise AND is clear for you, and this bitwise OR is clear for you. Whereas next operator that we are having, that is the XOR. XOR is basically what? If either of the input, if either of the bit is 1, I'll be having the, if only one bit is 1, simply, if either only one bit is 1, I'll be considering 1. That means this will be 0. This will also be 0 where both the values are 1. Where I am having single bit as a 1, I'll be getting 1 for that. Otherwise, I'll be getting 0. If both the bits are present, I'll be getting 0. Now, next we are having a NOT. NOT is basically what? Whatever value that I'll be having, it will invert the bit. For example, if I'm having this representation for the 4, and if I apply the bitwise NOT on that, what output I'll be getting? I'll be getting, for 1, for 8 I'll be getting 1, for 4 I'll be getting 0, as it was previously it was 1, for 2 I'll be getting 1, for 1 I'll be getting 1. The output that I'll be getting for 4 is 8 plus 2 10, 10 plus 1 11. I hope this is clear as well. Now let's understand all these 4 with the help of code first, then we will move forward. Let's say I'm taking any variable a, I'm providing value 4, I'm taking other variable b, I'm providing value 2. Firstly I'm applying bitwise and on that, let's run this particular portion. So you can see what I'm getting over here. I'm getting 0, the way we were getting 0 over here when we try to solve this solve this manually as well. We were getting 0 for this when we were applying the AND on that, bitwise AND. Now instead of applying the bitwise AND, if I'm applying, let's say, bitwise OR, Remember this, the symbol that we'll be using, that is this particular. Let's run this. So you can see what we are getting. We are getting 6 over here. And what we were getting when we were solving this manually, we were getting 4 plus 2, that was 6 at the end. I hope this is clear. Now, bitwise XOR, that is basically what? If any of the input is 1, I'll be getting 1. If both the inputs are 1, I'll be getting 0. If both the inputs are 0, I'll be getting 0. Now let's run this. So again, I'll be getting 6 over here. Okay, because I am having 0, 1, 0, 0, 0, 0, 1, 0. So this will be remain same 6 as well. To understand the difference, let's say we are taking any number that is representing both. Let us consider 3 and 1. A bitwise representation for 3 will be 0, 0, 1, 1, 1, 0, 0, 1, 1, and for 1 that will be 0, 0, 1. So if we run this, as you can see over here, the output that you will be getting will be 2 over here. Even if both the values at the last bit are 1, still I am getting 0 over here, right? Let's see this. Let's see this. If I'm getting a is equal to 3, the representation will be, if I'm using 8, 4, 8, 4, 2, 1, that will be, for 3 this will be 1, 1, 0, 0, and for 1 that will be 1, 0, 0, 0. And the using bit of using this XOR, what will be getting, 0 and 1 and 1 both will be 0 as both the inputs are present. One input is present, I'll be getting 1, both are 0, 0, 0. The output that I'll be getting at the end is 2. And this is what we are getting when we are executing that. We are getting 2 at the end. When we are running this, what we are getting at the end, we are getting 2 at the end. I hope this is clear. Now next one that we are having is a bitwise NOT. That is basically what? If the value is present, I'll be getting, if the value is present, I'll be getting 0. If the value is not present, I'll be getting 1. For example, for this 5, I am applying bitwise OR on this. I'm assigning a is equal to 10 and printing NOT of that. So you can see you are getting minus 11 over here. Means wherever the value is present, that will be getting the 0. Wherever value is absent, there we are getting the 1. I hope this is clear. Then moving forward to left shift and right shift. These two are very important. And what we are supposed to do over here, in this what we do, we shift the values. Okay, for example, I am having, take a simplest scenario, I am having the value 5. Okay, I am applying the left shift of 2 on this, or you can say simply what I am doing over here, I am taking any value 5. For that I am applying left shift of 2. Take a simple example. If I'm writing 5 left shift of 2, this simply means what? I'll be shifting the bits towards left side, or I'll be shifting 2 bits towards left side by 2. Simply, let's say, for example, how to represent this 5 in form of binary, that will be 1, 1, 0, 0. Okay, now I want to shift towards left side by 2. That means this side I'll be having 16, other side I'll be having 32 as well. Okay, now consider this shifting towards this side toward by 2. This means here, over here I'll be getting this will be the one shift, right? This will be the second shift. That means I'll be starting from here 0, 1, 0, 1. The value that I'll be getting for a 5 will be, now this will be 4, 4 plus 16, I'll be getting 20. If I am applying left shift of 2 to 5, value 5, I'll be getting 20 over there, because I am shifting bits towards left by 2. I hope this is clear. Why we are understanding the logic, the manual understanding behind this, because अगर हमारे पास कोई कोड हो और हमें उसका आउटपुट हो, अगर हमें ये मालूम नहीं होगा कि वो कैसे वर्क कर रहा है, विल नॉट एबल टू इंटरप्रेट कौन सा लॉजिक लगाया हुआ है, और वहाँ पे लॉजिक का नाम मेंशन नहीं है, तो दैट्स व्हाई वी ट्राइंग टू अंडरस्टैंड द manual implementation of this as well. I hope this is clear. Whereas right shift is basically what? Instead of moving values towards left side, instead of moving values toward this side, we will be moving values towards this side. Okay, now let's say for 5 only I'm applying right shift of 2. What will be that? That means this will be toward this side, two values will be over here. I'll be getting 0, I'll be getting 1, I'll be getting 0, I'll be getting 1. That means if I try to convert, if I try to apply the right shift of 2 on 5, I'll be getting 1 at the end as output. I hope this is clear. Let's understand this in a better way with the help of code. For example, let's say I'm having a is equal to 5. I'm applying firstly left shift of 2. Let's run this. You can see over here what we are getting. We are getting 20 over here. If I'm applying left shift of 3, that means I'll be moving bits towards left side by 3. You can, now I'll be getting 40 and so on the way you are applying. I hope this is clear how this is working. If I am applying a right shift of 2 on 5, I was getting, when I was implementing manually, computing manually, I was getting 1. Now see what we are getting at end. We are getting 1 at end. I hope bitwise operators are clear. Now remember the difference between logical operators and bitwise operator. Okay, in logical operators we are having and, we supposed to write and, whereas here we supposed to use operator as and. In simple logical operator, both statements need to true, then we are getting true as output. Whereas in logical operator, both the inputs need to high for providing as a higher input in a binary form. In the binary form, what is the higher input? That is 1. That means both the values need to 1 for providing me a 1 as output. I hope this is clear. Whereas in our logical or, any one statement needs to true for providing as a true as output. Whereas in logic, in bitwise or, what we are doing, we are checking if either of the input is higher, we will be getting higher value at end. I hope this is clear. Bitwise operators are clear for everyone. In case you are having any doubt in any bitwise operator, do put in the comment section below. Let's move forward to our assignment operators. So next we are having assignment operators. So as we know, assignment operators are simply for assigning the value. For example, I am creating any variable a for which I am assigning value 7. This simply means I have assigned a value 7 to the a operator. And what assignment symbol I am using simply is equal to I supposed to use. Now, other is basically what? Other operator is plus is equal to. This is basically, okay, this type of assignment is basically known as an augmented assignment operator. Okay, this when we are applying the operation and then saving the result in a same variable. So this is basically an augmented assignment operation, or we call it a compound assignment as well. So what we are trying to do over here, let's say for example, I am having any value in variable 7. For example, what I am trying to do, if I'm writing something like this, that simply means whatever value that is residing in a variable beforehand, in that only I am adding 7. That means the new value will be saved in a x variable. In this scenario, that new value will be saved in a variable only. For example, this is something like this. I am having any variable to which I have assigned the value, let's say 2, and I am writing a is equal to plus is equal to 7. Now this simply means what? This simply means what? In A, what I am doing, I am whatever value that is stored in A, that is 2, I am adding this 77 into that value, okay, and saving the result into A. That means if I now reprint the result of what is stored in A after this operation, I'll be getting 79 as my output. Okay, let's understand this with help of code. So simply let's say I am writing a is equal to 5, a is equal to plus is equal to, let's say 7 I am adding. I am printing a. So now the new value will be getting updated into a. The output that I'll be getting after this operation will be 12. So you can see over here. So this type of assignment is known as augmented assignment or compound assignment. That means we have saved any value in a, in that value only we are adding 7, in that variable only we are making a change, in that variable only we are saving a new value of a. You can understand like this. If I am writing something like this is basically what, this is the other side. I am applying the whatever value that is stored in a variable, I am subtracting 7 from that and saving that result into the a again. That means again I'll be getting 2 over here, minus 2 over here. 5 minus 7 will be minus 2. Okay, for example, I'm using multiply over here. That means whatever value that is stored in a, that will be multiplied by 7. That means 7 multiply 5 multiply 7, that will be 35, and so on. The same way we can try for, we can do for this division. We can do same for our floor division. Okay, so this particular sort of assignment is known as augmented assignment. In augmented assignment, what we are doing, we are saving a value to the same variable. Okay, to the same variable in which we are applying the operation, on which we are applying the operation. I hope this is clear. Augmented assignment simply means, for example, instead of writing like just remember like this scenario. Instead of writing, I'm not writing like this, x a is equal to a plus 2. Instead of writing this a again, what I am doing, I'm simply writing a plus is equal to 2. This simply means the same. Both the things are same. If I apply this operation, this will give me same output. If I apply this will give me same output. I hope the assignment operators are clear for everyone. Let's see one more example. Okay, after that we'll end this video. For example, if I'm writing multiply 2, if I'm writing like this, I am getting 35 as output. If I don't want to write this a again, what I can simply do, suppose to put operator over here, and we are getting 35 over here. I hope the augmented assignment is clear for everyone. In case you are having any doubt, please put your doubt in comment section below. And in case you are having any issue in any type of operator that we have discussed so far, assignment operator, logical operator, bitwise operator, comparison operator, and assignment operator, please do put in comment section below. Okay, thanks for watching, and try to mention all your queries in comment section below. And once again, thanks for watching.